Alright, so we're going to continue graphing linear inequalities in a plane, and this is given to us in standard form. So I have this graphic up here just to review the three forms of a line, or the three types of forms we can get the equation in, I'll say it that way. So standard form is just ax plus by equals c. Slope-intercept form is y equals mx plus b, so this one is very useful because I know where my y-intercept is from this number being added or subtracted, and I know where my slope is because it's the number that's being multiplied by x. So this is a very useful format. Point slope is another format that's pretty useful because it's y minus y1 equals m times the difference of x and x1. So what this is it's a point and a slope instead of slope and an intercept. So I know right away what a point is on my line because I have x1 and y1, and then I know what my slope is because it's being multiplied by the x difference here. The y and the x here are the same thing as the y and the x in this one and the y and the x in this form. So there's always an x and y there that stay part of the equation, but these two are very useful equations. You can grab information from them very quickly. The standard form, you can't grab it quite as quickly, so we're going to have to do a little bit of work to get the points. So we want to know what is the y-intercept and what is the slope. So we can quickly turn this into slope-intercept form by just getting y by itself. So if I start working on this one, so I brought it down here, I want to get y all by itself. So I'm going to add this 2x to both sides because I want to move that negative 2x over here with the 12. So I have 3y is less than 2x minus 12. So it's close. It's almost there. I just don't want this 3 with the y. I want to divide both sides by 3 so that I just get y by itself. So now the 3's cancel and I have y is less than 2/3 because 2 gets divided by 3. 12 also gets divided by 3. So be careful about that. That's probably the biggest thing I see forgotten, is that students divide the first part but not the second part. So we get minus 4 here because 12 divided by 3 is 4. Alright, so now I have my y-intercept. That's negative 4, so I put that over here. And then my slope, well, that's going to be the 2/3. So there it is right there. So, and this is by no means the only way to do this. You could also find the y-intercepts. I know we've practiced that before, where, if you want to know what the x-intercept is, you make y 0 and solve for x. If you want to know what the y-intercept is, you make x 0 and solve for y. So there's different ways for you to figure that out. But I think this is definitely the easiest way, is just to change it into this slope-intercept form to graph these two pieces. So now I know my y-intercept is, so I'm going to go down 1, 2, 3, 4, and I'm going to place my y-intercept. And then I'm going to use my slope, which is rise over run. So I'm going to rise 2, 1, 2, and I'm going to run 3 to the right because it's positive. I'm going to place my point. And now I have to decide, is it a solid dot or is it a dashed line? Sorry, not dot. Is it a dashed line or a solid line? I said that funny. So I'm going to come over here and look at my inequality, and I can look at it from either one because it didn't switch around. So it's a less than. It doesn't have an equal to sign under it, so it's just going to be dotted. So there's my dotted line. Now I can do one of two things. I can do a test point. So testing 0, 0, that's always the one I choose as long as it's not on the line. It's a super easy one to choose because it eliminates things very quickly since we're multiplying by 0. You can also use the method I talked about in the previous video, where you can go to the y-intercept and then look at your inequality. If it's less than, you go down. If it's greater than, you go up. So in this one, if I'm looking at my y-intercept, and since it says less than, I'm going to go down. So this whole bottom area is what I'm going to shade. Remember, the shading, that's the solution. I can pick any point in that shaded area, and that is a solution of this inequality. So if I look at the test point, I'd have negative 2 times 0 plus 3 times 0 is less than negative 12. And I'm using the standard form that they originally gave me. That's where I got the pieces here. So it's negative 2, I put 0 in for x, positive 3, I put 0 in for y, and less than negative 12. So 0 plus 0 is 0, and less than negative 12. Well, 0 is not less than negative 12, so that's false. So what that means is 0, 0 is not part of the solution. So I'm not going to shade on the part that that side of the line, I'm going to shade on the other side of the line, which is what we already discovered by looking at the y-intercept and going less than that. So just two different ways to kind of look at that, deciding which way to shade, but just keep in mind everything shaded here is a solution to this equation or this inequality, except for the line because it's dotted. Remember, dotted line means it's not actually included. It's a starting point, but it's not actually part of the solution. A solid line means that it is part of the solution and it's a starting point. So, all right, so that's graphing an inequality in standard form. So I hope that helped, and I will see you in the next video.